Hello everyone, welcome to this course Remote Sensing Principles and Applications. I am Dr. Ishwar, working as Assistant Professor in the Department of Civil Engineering and also associated with the Interdisciplinary Program on Climate Studies at the Indian Institute of Technology, Bombay. So, what are we going to see in this course? Remote sensing is a fast emerging technology in the last few decades. It has grown tremendously. In this particular course, we are going to see what are the basic physical principles behind remote sensing, especially in the optical and thermal domains. We will also be able to understand the different terminologies associated with remote sensing. What are the different satellite data sets available to us and what those satellite data sets contains. And finally, we will also get to know or get introduced to few applications of remote sensing at the end of this course. So, even though these lectures will be as self-contained as possible, for your own understanding and appreciation, I would suggest few textbooks for you all to go through. So, like some of the textbooks are Remote Sensing of the Environment, an Earth Resource Perspective by John Jensen, the classical textbook Remote Sensing and Image Interpretation by Lillesand and Kiefer, Physical Principles of Remote Sensing by W.G. Rees, and the Fundamentals of Remote Sensing by Dr. Joseph and Jagannathan. So, if you want to get like a basic introduction to the concepts, then the textbook by Lillesand and Kiefer and Jensen would be like the best suggested ones. If you want to understand the physical principles or go a little bit deeper into the concepts, I would suggest you to look at the textbooks by Joseph and Jagannathan and W.G. Rees. What exactly remote sensing is? Normally when we look at our newspapers, we will see like this is the image, the cloud image for today, or in TV they will say like they will show an image like an India map and they will tell okay a cyclone is approaching, the cyclone is headed towards BISAG coast, the cyclone is headed towards Odisha, all these things they will say, and we all like will be like recognizing it as a satellite image. That is true, it is like a satellite image processed to some degree. So, just by looking at the image, what we will be able to do, we will see okay there is a cyclone here and the path of the cyclone is moving like this. All such information we will get by seeing those images taken from the satellites. Exactly that is what remote sensing is as a basic definition. So, remote sensing is a technology in which we obtain information about some feature or a phenomenon on the earth surface through data collection and analysis, in which the data is collected in a non-contact manner or without being in physical contact with the object of our interest. So, one of the best example of remote sensing what we do in normal life is our own vision. Like whatever objects we see the objects from a distance, like we use the natural light coming from the sun or we use some artificial light source like bulbs or something which falls on the object and the object will reflect light and our eyes will receive it and we will see okay there is a table in front of me, the door is in that direction, I should enter through that door. So, all this kind of processing we do unknowingly through the data we collected through our eyes. So, our eyes acts as a sensor in that sense and our brain is the data processor. So, remote sensing is essentially a data acquisition technology which we can use for various applications. As I said before, remote sensing occurs in nature itself. The process of human vision, not only human, the vision of all animals is an example for remote sensing. Whatever we see it from a distance. The sound we hear, say for example, if a baby is sleeping in the bedroom and we are sitting in the living room, if the baby suddenly wakes up and cries, we hear it from a distance and we enter the room, take the baby and pat it. So, this information collection, okay the baby has woken up and it is like crying now, that information collection happens remotely. So, the process of our hearing is an example for remote sensing. So, not only this, like even bats when they fly they avoid obstacles by sending ultrasonic waves and hearing the reflection back they avoid the obstacles and move away from it. These are all examples of remote sensing which occurs in nature. So, the technology that we are going to learn in this course is an extension of this natural process to study earth and various features associated with earth. Truly speaking, remote sensing is not restricted only to earth. Remote sensing can be carried out in even in like for planets in solar system and far beyond, people are doing it. But in this particular course, we will be concentrating on remote sensing of Earth's surface and its applications. We will not be looking on remote sensing of other planets. So, this is a typical remote sensing system. So, what a remote sensing system consists of? We will always take an analogy with the process of human vision and then we will learn this. So, for remote sensing to occur, first there should be an object of interest. Let us say the object of interest here is marked as point C. This is the object of our interest. So, in order for us to see that particular object, we need some light source, and that light source during daytime it is the sun, or during, if we are within our rooms, it is the bulbs that we use. So, we need a source of energy that transmits energy towards the object of interest. Okay. So, this is the object of interest. What happens then? The source of energy transmits some energy towards the object, it gets reflected by the object of interest and come towards the sensor. Say if you take analogy of human vision, the sensor is eye, our human eyes, or if you take our normal remote sensing, the sensor is the sensor located in a satellite. So, this energy is reflected back or emitted, whatever, we will see it later these terms in detail. So, the reflected energy goes towards the sensor and the sensor collects it. So, now the sensor will transmit the data back to Earth. So, this is known as data transmission, and this transmitted data will be stored most likely in form of images, most likely, like there are other ways of processing and storing remote sensing data, but mostly we are used to seeing satellite images and working with it, and the final step is application of this data, So, I just go back to the previous slide, the object of interest is here and sun is there to provide energy, our eye acts as the sensor. So, the brain acts as the data processor and then our brain takes decision based on whatever happens. So, the data transmission happens in this particular way, like between the eyes and the brain the data transmission occurs. So, this is like a very simple analogy of remote sensing, that what we do with the help of satellites. And this particular energy, what the source of energy senses or which carries the signal, we call it as medium that carries the signal. So, this particular medium, like after the energy being reflected by the object, it carries the signal and it reaches our eyes. So, basically if an object is appearing green, what the object is doing, whatever the sunlight comes in, it is absorbing all other energy other than green and only green is reflected back. So, this particular object is reflecting green color and it is absorbing all other color light that is coming from the sun, and that is why we are seeing that particular object as green. If an object appears white to our eyes, it is reflecting almost all the colors from the sun equally. That particular objects will appear white to our eyes, something like that. So, the basic remote sensing that we do with respect to satellites has a very good analogy with the process of human vision. What are the advantages of remote sensing? First of all, remote sensing is a non-contact and non-intrusive way of data collection. That is, as I said in the definition itself, remote sensing is a non-contact way of data collection. Being non-contact, we will not be disturbing the object or feature of our interest. So, if I want to collect data about some object, I need not go touch the object or disturb the object. So, from a distance I can collect the data, that is non-contact and non-intrusive. In addition to this, being non-contact way of data collection, it provides access to almost all points on the earth surface where we cannot physically enter. That is, say like we are going to see a hurricane and track how the hurricane is going to progress, where it is going to change direction. We cannot go and collect data within a hurricane itself, it is like highly risky. So, what we can do, we can collect data from satellites safely sitting from the satellite control center, process the data and collect more information about the hurricanes. that is possible. So, first major advantage is it is non-intrusive, which will not disturb the object of our interest, and then it provides access to almost all points on the earth surface. Then remote sensing provides repeated data, like the data collected over a particular region can be collected again and again based on our needs, which will tell us how that particular object or phenomenon is changing with time. Say for example, one of the major applications of remote sensing is agriculture. So, for agriculture we all know crops has a sowing date, crops will grow, crops will finally like reach the harvest stage, people will harvest it, then everything will be removed from that particular parcel of agricultural land. So, crops follow a physical phenological cycle right from sowing date to harvest date. So, as the plant grows, the signal emitted by the plant will be different, and just by seeing this change in signal we will be able to understand what is the condition of the plant, whether it is growing good or not. So, the temporal evolution of the crop cycle can be studied by taking multiple images at different times in between the phenological cycle. So, the repeated information provided by remote sensing offers us to study how the object or the phenomenon of our interest evolves with time. The next major advantage of remote sensing is synoptic coverage, that is it provides a glance of a large portion of earth surface in a single instance. This is really necessary for people who works on meteorological applications. They want to track cloud movements, they want to track hurricane movements, they want to track how dust storm is moving. Normally like dust storm from Saharan desert will move to South America, all these things will happen, or like normally we see like the smog coming in from like stubble burning, it will reach the next states and it will affect people over there. This is like every year it is occurring in India also. So, for such studies we need to look at a much larger area, much larger than what our eyes can see or what we can like sense by our local means. So, that is called synoptic coverage. So, remote sensing satellite image can provide you coverage of entire country, entire state or entire continent, sometimes even the entire globe, depends on where the satellite is located. That kind of synoptic coverage will help you to understand the phenomenon in a much more clearer way. Then next major advantage is remote sensing provides global or regional coverage. Most of the satellites are put in orbits to either look at the same area again and again continuously, or to cover the entire globe by taking images repeatedly at different portions. So, either based on the satellite orbits you will be seeing the same area continuously, or you will be able to cover the entire globe. So, it provides a regional level or a global coverage which will be helpful for various applications. Then the most critical thing what I will say as the advantage is remote sensing enables us to see the object in different portions of the energy band which human eyes cannot see. See, when I talked about the human analogy of remote sensing, I said like okay, what color the object reflects, it will be our eyes will perceive the object in that particular color. Say if in a green object it is reflecting only the green energy, our eyes can only see green. So, what essentially happens is our eyes are tuned to the white light that comes from the sun. Whatever energy coming within that particular energy level our eyes can sense, but sun is a good source of energy in different portions of electromagnetic spectrum. We will see what electromagnetic spectrum in the later classes. So, sun provides energy in the very large portion of electromagnetic spectrum, and each object will behave differently in different portion of this incoming energy which our eyes cannot see. So, remote sensing through the use of different sensors or different detector elements helps us to see the same object in different way by helping us to see in different bands of energy. So, this kind of multispectral information, we call this as multispectral information. So, this multispectral information helps us to understand that particular object in a much more detailed manner than what our eyes can see. So, a very good example of how multispectral remote sensing will help us is given here. So, this particular image is taken over United States by a sensor called MODIS. This is like a remote sensing sensor in 2 different satellites. So, what these bands essentially mean? These bands essentially mean different portions of the energy spectrum that is coming from the sun. Like what our eyes can see is very small amount of energy from the sun, but sun is giving energy in many different portions of the spectrum. So, each band is a one small portion of spectrum. So, the same area imaged by some sensor in space will give us a completely different look of the land surface. Say band 2, we can see the land surface primarily here, band 6 we can see, band 26 land is not visible, but we are seeing this cloud patches very clearly, like here this cloud patch is not visible in band 2, here it is very much visible. Whereas in band 27, whatever we are seeing entirely is whatever is present in the atmosphere, and we are not seeing anything related to ground. So, same area, same sensor, but by looking in different portions of energy, we are getting different information. In band 2 and band 6, we are getting information about the ground surface. In band 26, we are able to see some clouds. In band 27, we are seeing or getting information about the atmosphere. So, this sort of multispectral information will provide us many different ideas about the object of our interest. So, this is another example of how multispectral information will help us. Again, this is like same area covered by a sensor called thematic mapper. This sensor is in a satellite called Landsat. Okay. So, again this is band means different portions of energy. So, what happens in this particular band 1, what are we seeing? We are seeing like 2 reservoirs, the reservoirs appear little bit brighter, some land surface. Band 2, it appears bit darker. If you look at band 4, we are able to clearly see the reservoir in a much darker tone. So, this is like water bodies or 2 reservoirs, and this is like land surface. So, essentially each band gives us different information about the same object of our interest. So, basically just to summarize what we have learnt in this particular lecture. In this particular lecture, we have learnt what remote sensing is, we have learnt what a remote sensing system comprises of, and then we have learnt a remote sensing system in analogy with human vision, and then we saw the advantages of remote sensing. One of the major advantages, the multispectral information provided by remote sensing data, and we also saw 2 examples of what multispectral information is and how the images acquired at different portions of energy will look for the same area. Thank you very much.